Welcome to lesson 2.1. Today we're going to talk about the early history of chemistry. As you can see from this slide, a couple of different applications before 1000 BC, use of embalming fluids. Ancient Egyptians used those for royalty and others who passed. We also used chemistry to process natural ores to produce metals. We needed those for, perhaps decorating some royalties castle, in terms of ornaments. We also needed those for weapons. The Greeks, however, were the first that have been credited with, talking about chemistry and studying chemistry and philosophizing about chemistry. But their first periodic table only had 4 fundamental substances. It was earth, fire, air, and water. Obviously, that'd be much easier than the 118 that you currently have on your periodic table. But then the Greeks started having conversations about matter, and they came to the conclusion that matter was infinitely divisible. You could continue to take some matter and divide it into smaller and smaller and smaller substances. And then the alchemist took over. An alchemist is a chemist who tries to take a very common metal and turn it into a precious metal. Obviously, this would be, even today, this would be very, very financially beneficial. It can't be done because metals are elements, and metals are just simply that metal. You can't change it into another one. Those 2,000 years weren't completely lost, though, because we were able to discover several elements, and we learned to prepare some of the mineral acids that we'll talk about later. In the 16th century, some scientists, kind of moved away from the alchemy a little bit, and they, then here's a couple named here. George Bauer, he developed systematic metallurgy. They were doing that before 1000 BC, but they weren't coming up with very high yields. So what they were doing is they were taking ore and actually refining it into the metal, and by systematically doing that, he could get better yields. Another scientist, Paracelsus, he discovered the medicinal application of minerals. You probably take a vitamin supplement every day that has minerals in it, and he started looking at why those minerals are important and what systems they affect. Robert Boyle is actually the first chemist that took quantitative measurements, and so he's almost by some considered the father of experimentation. And you'll notice from this statement here, he was looking at pressure versus volume, but he was taking quantitative measures with that. Pressure volume is Boyle's law. We'll talk about that more later. Robert Boyle also developed the first experimental definition of an element. He said it's an element unless it can be broken down into 2 or more simpler substances. So an element is a pure substance that cannot be broken down into 2 or more simpler substances. But he didn't consider metals as true elements, so he thought we could still manipulate those to make other metals. And so this is kind of Robert Boyle's downfall and why he doesn't get the picture in the Hall of Fame, because he still believed in alchemy. In the 17th and 18th century, this scientist named George Stahl presented the concept of something called phlogiston, and he basically said that if something is burning, it gives off this substance called phlogiston, and what that phlogiston does is when it collects, it puts the fire out, it stops the burning. He didn't realize that, like in a closed container, that you were actually, once the oxygen was consumed, combustion couldn't occur anymore. Another scientist named Joseph Priestley is credited with the discovery of oxygen gas, and with oxygen gas, they noticed it vigorously supported combustion, and so since it supported combustion, it was supposed to be low in the phlogiston, and it was originally called dephlogisticated air, because they didn't understand that oxygen was actually part of the combustion process. So next time in lesson 2.2, we're going to talk about the fundamental chemical laws, and we're going to start talking about law of conservation of mass, law of definite proportion, and so on. So until next time.